Something is happening right now at this very moment that no headline is treating with the urgency it deserves. 15 billion miles from where you are sitting, a machine the size of a small car, built with technology that predates the personal computer, soldered by hands that have since aged and retired and, in many cases, left this world entirely, is tumbling silently through the blackest, coldest, most hostile environment the human mind can conceive of. It has no backup crew. It has no rescue vehicle waiting on standby. It cannot be touched, repaired, or physically reached by any method known to science. And yet it is still alive, still transmitting, still sending whispers of data across a distance so incomprehensible that the signal traveling at the speed of light, the fastest thing in the universe, takes more than 23 hours just to arrive. But here's what nobody is saying loudly enough. That signal is getting quieter. The power is dying. The instruments are being switched off one by one, like a surgeon making careful incisions just to keep the patient breathing. And the people trying to save it are working against a clock that nobody built and nobody can stop. This is not a story about space. This is a story about what happens when humanity reaches the absolute edge of its own capability, and then tries to push a little further anyway. Voyager 1 launched on September 5th, 1977. To put that in context, the world had no internet. No mobile phones, no GPS. The most powerful computers on Earth filled entire rooms and couldn't do what your wristwatch does today. The engineers who designed and built Voyager 1 were working with slide rules, punch cards, and an audacity that, in retrospect, borders on insane. The spacecraft launched in 1977 and is now the most distant human-made object in existence, traveling through interstellar space beyond the edge of the sun's influence. Nobody genuinely expected it to still be functional approaching its 50th year of flight. Nobody planned for this. Nobody wrote a manual for keeping a 1970s-era spacecraft operational across interstellar distances in the year 2025 and 2026. There is no manual. There never was. And that is precisely why what NASA's team has been doing in recent months is so extraordinary and so terrifying at the same time. In late 2023, one of the most distant machines humanity has ever built started talking nonsense. Voyager 1, more than 24 billion kilometers from Earth, began sending back a meaningless repeating pattern instead of data, and it kept doing so for about 5 months. 5 months. Imagine waking up every morning, walking into a mission control room, staring at your screens, and seeing nothing but gibberish coming back from the edge of the known universe. Imagine knowing that the problem exists, that the spacecraft is out there, still flying, still functional in some form. But you cannot understand what it is telling you, and you cannot go fix it. You cannot send a technician. You cannot do anything except sit, think, hypothesize, and send commands that take nearly a full day just to arrive. That is the reality these engineers lived with for 5 months. In 2024, engineers brought it back, not by sending anyone to fix it, which is impossible, but by remotely rewriting and relocating pieces of its 46-year-old software around a dead memory chip, with every command they sent taking the better part of a day to arrive. Think about what that means. They performed open-heart surgery on a spacecraft at the edge of interstellar space using only radio waves and mathematics and an intimate knowledge of code written before most of their own team members were born. And it worked. The first serious attempt succeeded. Voyager 1 came back to life. The world celebrated. Scientists cheered. And then, almost immediately, the next crisis began. Because the thing about Voyager 1 is that saving it once was never going to be enough. The fix bought time, not permanence. That sentence, understated as it is, carries an enormous weight. Every solution the team devises is a temporary solution. Every repair is a patch. Every triumph is a reprieve. The spacecraft is not getting better, it is getting older. And the forces working against it are not mechanical failures or software glitches. They are the laws of physics themselves, and the laws of physics do not negotiate. Here is where the story deepens into something that feels almost fictional in its complexity. Voyager 1 maintains its orientation in space using thrusters, small rocket firing systems that keep the spacecraft pointed correctly so that its antenna remains aimed at Earth. Without that orientation, the antenna drifts, the signal weakens, communication breaks down. And if communication breaks down for long enough, the mission ends, not with an explosion, not with any dramatic finale, but with silence. Just silence, slowly spreading across the void. Over the decades, the spacecraft's primary attitude control thrusters began to degrade, leading engineers to switch to backup thrusters in 2004. However, these backups also started showing signs of wear, with fuel lines becoming clogged due to residue buildup from hydrazine propellant. Hydrazine is the chemical fuel that powers Voyager's thrusters. After nearly 5 decades in the extreme cold of deep space, the residue from that fuel has been slowly accumulating inside the fuel lines, narrowing them, restricting flow, building up like arterial plaque in a body that has lived far longer than anyone expected. Scientists estimated those thrusters could fail as early as fall 2025. Read that again. The backup thrusters, the ones they switched to after the primary thrusters were abandoned, were themselves on the verge of failure. And if those thrusters failed, Voyager 1 would begin to drift. Its antenna would wander away from Earth. The signal would be lost. And with it, humanity's only direct connection to interstellar space would simply vanish. Even if the engineers decided to act immediately, even if they devised a solution overnight, there was a hard external constraint they could not control. From May 4th, 2025 through February 2026, Deep Space Station 43, a 230-foot wide antenna in Canberra, Australia, that's part of NASA's Deep Space Network, would be undergoing upgrades. It would be offline for most of that time, with brief periods of operation in August and December. Now, understand what that means. Although the Deep Space Network has 3 complexes equally spaced around the globe, in Goldstone, California, and Madrid, in addition to Australia, DSS-43 is the only dish with enough signal power to send commands to the Voyagers. You could have every other antenna in the world pointed at Voyager 1, and it would not matter. The only instrument on the surface of this entire planet with the physical capability of sending instructions to the most distant spacecraft in human history was about to go dark for months. And during those months, if something went wrong with Voyager 1, if the thrusters clogged and the spacecraft began to drift, there would be nothing anyone on Earth could do about it. This was not a hypothetical. This was a countdown, and the engineers knew it. Without roll thrusters, Voyager 1 would lose its ability to stay properly oriented and eventually drift out of contact. To make matters worse, the only antenna on Earth with enough power to send commands to the Voyager probes was undergoing an upgrade shutdown until next February, with only a couple of brief operational windows in August and December. The pressure was extraordinary. It was not simply a matter of solving a technical problem. It was a matter of solving a specific technical problem in a specific way, before a specific date, with a 46-hour round-trip communication delay baked into every single step of the process. As options dwindled, engineers revisited the primary roll thrusters to determine if they could be revived. They went back, they looked at the old records. They decided it was worth trying to turn the heaters back on. The primary roll thrusters, the ones that had been abandoned and left dormant since 2004, had been sitting unused for 21 years in temperatures hundreds of degrees below zero. Nobody knew with certainty what state they were in. Nobody could know without trying. And trying, it turned out, carried its own terrifying risk. The mission team had to take a risk by switching Voyager 1 to its primary roll thrusters and turning them on before attempting to fix and restart the heaters. The heaters could only function if the thrusters are also switched on. If Voyager 1 drifted too far from its guide star, the spacecraft's programming would trigger the roll thrusters to fire. But if the heaters weren't turned on yet at that moment, the automatic sequence could have triggered a small explosion. Let that land for a moment. While attempting to save the spacecraft, there was a real possibility of destroying it. The very act of rescue could have been the killing blow. They were threading a needle across 15 billion miles of absolute darkness, using commands that took 23 hours just to arrive, and the margin for error was essentially 0. One mistimed automatic sequence. One unexpected drift. One moment where the spacecraft's own survival programming triggered before the humans were ready, and 48 years of exploration, of discovery, of pushing humanity's reach further than it had ever gone, would end in a silent, invisible detonation in the depths of interstellar space. This is not chaos. This is what engineering looks like at the very edge of the possible. On March 20th, 2025, according to NASA, the team watched the returned data as Voyager executed the command sequence. Within about 20 minutes of the relevant telemetry, the temperature of the thruster heaters rose sharply. The old heaters were alive. The thrusters once considered dead had been pulled back into service. 21 years of dormancy, ended by a radio signal from a dish in Canberra, Australia. 21 years of cold and silence and neglect, and the thrusters came back. The heaters warmed, the system responded, and the team had secured, at least for now, the ability to keep Voyager 1 oriented, to keep its antenna pointed at home, through the long months when DSS-43 would be unavailable and no one on Earth could reach it. The new fix to the vehicle's original roll thrusters, out of action since 2004, could help keep the veteran spacecraft operating until it's able to contact home again next year. But what nobody is saying loudly enough is that this was one more patch, one more temporary solution to a problem that is not temporary. The underlying reality has not changed. It is, if anything, accelerating, because power is the final countdown, and it has been running since 1977. Voyager 1 1 is powered by radioisotope thermoelectric generators, RTGs, devices that convert the heat produced by decaying plutonium into electricity. They were designed to be robust, long-lasting, and independent of sunlight, which matters enormously when your spacecraft is billions of miles from the sun. But plutonium decays at a fixed rate. You cannot replenish it, you cannot slow it down, you cannot negotiate with radioactive physics. The power output of Voyager 1's RTGs has been declining by about 4 watts per year, and as of April 2026, they are producing less than half their original power. Less than half of the power they were generating when Voyager 1 first lit up its instruments and began its journey through the solar system. And that number does not stop declining. It never stops. It falls by approximately 4 watts every single year, year after year, with the mathematical precision of a clock that cannot be rewound. Without shutting off instruments, the agency said the spacecraft might have had only a few more months of power before end of mission had to be declared. So the team began making sacrifices. Planned, deliberate, irreversible sacrifices. Years earlier, scientists and engineers developed a step-by-step plan for shutting down systems in a specific order while preserving as much scientific capability as possible. Each Voyager originally carried 10 sets of instruments, and 7 have already been turned off. 7 out of 10. The cameras are gone. The ultraviolet spectrometer? Gone. The planetary radio astronomy instrument? Gone. The photopolarimeter? Gone. One by one, the eyes and ears of humanity's most distant explorer have been silenced. Not by failure, but by deliberate choice. The team chose to sacrifice these instruments so that others could survive a little longer, so that the mission itself could continue a little longer. Engineers at NASA's Jet Propulsion Laboratory sent commands to shut down the low-energy charged particles experiment aboard Voyager 1 on April 17, 2026. The LECP, an instrument that had been running essentially without interruption since 1977, was switched off. Once an instrument is switched off, however, the shutdown is permanent. Without power, the heaters lose power. Temperatures plunge, electronics freeze, and the hardware can never realistically be restarted. This is not a temporary sleep. This is not hibernation. When they switch off an instrument on Voyager 1, it is gone. The cold of interstellar space, temperatures near absolute zero, colder than anything you will ever experience, floods into the system within hours. Electronics that have not been heated freeze solid. Any possibility of reactivation disappears. The instrument joins the growing list of things Voyager 1 used to do and no longer can. And yet, and this is the part that feels almost miraculous, what remains is still working. Voyager 1 still has 2 remaining operating science instruments, one that listens to plasma waves and one that measures magnetic fields. They are still working great, sending back data from a region of space no other human-made craft has ever explored. 2 instruments, 2 functioning scientific eyes in the darkness of interstellar space, measuring things that nothing else humanity has ever built could measure from this distance, in this location. The magnetometer is reading the local magnetic field structure of the interstellar medium, the space between the stars. The plasma wave subsystem is detecting oscillations and radio frequency signatures in the ionized gas that fills the void between solar systems. Data that is, quite literally, irreplaceable. What most people are not seeing is that every single day Voyager 1 remains operational. It is generating scientific information that cannot be obtained any other way. There is no other spacecraft in interstellar space. There is no other instrument positioned where Voyager 1 is. Everything it measures alone. And when it goes silent, that measurement ends. Not pauses, ends. But here is where the story takes one final extraordinary turn. Because the engineers at NASA are not simply managing a decline. They are, against all probability, planning an upgrade. Engineers hope the latest sacrificial move can keep Voyager 1 operating long enough for the team to potentially roll out an upgrade, nicknamed the Big Bang, that could allow the record-breaking probe to continue exploring deeper into space, and perhaps even restart some of its science instruments. The Big Bang. That is what they are calling it internally, an upgrade. For a spacecraft nearly 50 years old, currently operating beyond the boundary of the solar system, with power levels below half their original capacity, and instruments being shut off to survive. They are planning to push new code, new capability, into a machine built before the invention of the compact disc. The team will implement the Big Bang on Voyager 2 first, which has a little more power to spare and is closer to Earth, making it the safer test subject. Tests are planned for May and June 2026. If they go well, the team will attempt the same fix on Voyager 1 no sooner than July. If it works, there is even a chance that Voyager 1's LECP could be switched back on. Think about what that means. The instrument they just switched off, the low-energy charged particles experiment that has been running since 1977, might come back. If the Big Bang works, if the power conservation measures succeed, if the thrusters hold, if the RTGs don't decline faster than projected. If DSS-43, when it comes back online, can establish clean enough communication to execute the upgrade without error. If. The entire future of humanity's most distant explorer is built on a cascade of conditional possibilities, each one dependent on the others, none of them guaranteed. According to informed sources within the space science community, the Voyager mission represents something that cannot be replicated. With the implementation of this power conservation plan, engineers believe the two probes could have enough electricity to continue operating with at least one science instrument into the 2030s. But they are also mindful that the Voyagers have been weathering deep space for 47 years, and that unforeseen challenges could shorten that timeline. The 2030s. Not the end of this year, not next year. But with careful management, with sacrifice, with ingenuity applied at a distance that strains human comprehension, Voyager 1 might survive into the next decade. It might keep whispering from the void for another 7 or 8 years. Every one of those years is a gift. Every one of those years is data that future scientists will spend decades analyzing. Every one of those years is proof that the people who built this machine in 1977 created something more durable than they ever imagined, and that the people keeping it alive today are equal to the task. But here is the truth that sits underneath all of the engineering victories and the temporary reprieves and the carefully worded mission updates. Voyager 1 is almost 50 years old. It has already survived computer faults, aging thrusters, declining heat, weakening power, and round-trip communication delays measured in days. Every future year depends not only on the plutonium supply, but on electronics built in the 1970s, continuing to behave well enough in a place no technician can reach. No technician can reach. That phrase carries everything. The fundamental reality of the Voyager 1 mission is that the spacecraft is beyond the reach of human hands, beyond the reach of any rescue, any physical intervention, any direct repair. The team at JPL can send signals. They can send commands. They can rewrite code and activate dormant heaters and choose which instruments to sacrifice. But they cannot touch it. They cannot see it. They cannot stand next to it and listen to what is wrong and work until they fix it. And they are doing all of this extraordinary, historically unprecedented engineering by remote control across a distance that makes the word remote feel inadequate. When the final science instrument is switched off, Voyager 1 will not immediately cease to exist. The spacecraft will continue flying. Its trajectory, calculated decades ago with extraordinary precision, will carry it onward into the galaxy long after the last signal fades. It will pass through the neighborhood of other star systems, not close enough for any encounter, but traversing the galaxy in silence for millions of years. Long after the Earth has changed beyond recognition, long after the civilization that built it has either transformed into something unimaginable or ceased to exist entirely. Voyager 1 will still be out there, a metal artifact of human curiosity, sailing through the dark. The real story, the one that mainstream coverage keeps missing, is not just about thrusters and memory chips and power budgets. It is about what this mission represents. Humanity looked at the sky and decided to know what was out there. Not approximately, not theoretically, physically, with hardware, with measurements, with instruments that could report back and say, here is what interstellar space actually feels like. Here is the magnetic field. Here's the plasma density. Here's the structure of the medium between stars, not as theory, but as data. And then we built a machine in 1977, launched it into the darkness, and it went further than any human artifact in history. And it is still going, and it is still talking to us. And a small team of engineers at the Jet Propulsion Laboratory in Pasadena, California, is doing everything humanly possible to make sure that conversation does not end 1 second sooner than it has to. That is the story. That is what is happening right now. The Big Bang upgrade is being tested. DSS-43 will have brief windows of operation in the months ahead. The plutonium in Voyager's RTGs continues its slow, unstoppable decay. The two remaining instruments continue measuring a region of space no other probe has ever reached. And the engineers continue their work, digging through 50-year-old technical records, modeling scenarios, writing commands that will take a full day to arrive, and then waiting another full day to learn whether those commands worked. What happens if the Big Bang fails? What happens if the power drops faster than the models predict? What happens if one of the two remaining instruments develops a fault that cannot be worked around? What happens if DSS-43, when it finally comes back fully online, cannot establish the signal quality needed to execute the upgrade? What happens to the science? What happens to the data? What happens to the only human-made object in interstellar space? Nobody knows, and that is the answer that nobody in any official press release is going to give you. Not because they are hiding it, but because uncertainty is the operating environment here. The team cannot know. They can calculate. They can model. They can plan contingencies and develop fallback strategies and squeeze every possible margin out of every possible system. But they cannot know. The spacecraft is 15 billion miles away, built with 50-year-old components, running on physics that cannot be negotiated with, in an environment that was not fully understood when it was designed. The future of Voyager 1 is genuinely open. It could defy every projection and keep operating into the 2030s. It could suffer an unforeseen failure tomorrow. Both outcomes are possible. Neither is certain. What is certain is this: the mission is not over. The signal is still coming. The data is still flowing. And the people trying to preserve both are doing something that has no precedent in the history of space exploration, or really in the history of human engineering at any scale. They are keeping a machine alive across interstellar distance, using the tools they have, solving problems that nobody anticipated, in a situation that every textbook would say was impossible. Somewhere out beyond the edge of the solar system, in the cold and silence that no human will ever physically visit in this lifetime, a spacecraft launched before most of its caretakers were born is still pointing its antenna toward home, still listening for instructions, still sending back what it finds. And on the other end of that signal, a small group of humans is still listening back. The question is not whether Voyager 1 will eventually go silent. It will. The question is what happens between now and then, whether the Big Bang works, whether the power holds, whether the thrusters, revived after 21 years of dormancy, remain functional through the months when no commands can reach them, whether the engineers find one more solution to one more impossible problem before the next crisis arrives. Something bigger is always coming. That has been the story of Voyager 1 for nearly half a century. And somehow, so far, the humans on the other end of that signal have always found a way to answer.